Okay, the task here is to sketch some graphs that have moduluses in them. And the thing to remember about modulus is that it can either have no effect, in which case this is saying y equals x, or it can cause a sign swap, in which case this is saying y equals minus x. So it's a combination of those two graphs. Okay, when you're sketching it, the point to start with is where those two things agree. So where x is minus x, which will be when x is naught. So when the thing inside the modulus equals 0, so the modulus equals naught when x equals naught. And then if I make the modulus, if x does equal naught, the thing inside the modulus is naught, what will y equal? Y will also equals naught, and this is going to be the point of my v. So the graph of y equals x is a very, you learn this one. You don't need to rely on any particular method to sketch it. This is the most basic modulus graph there is. Your graphics calculator can also plot this. This is a graph of y equals modulus of x. This side I can see is just the same as y equals x. It's a 45-degree line, and the other side equals y equals minus x, so we can see that on this side the modulus is having no effect, and on this side is where the modulus will have a sign swap. So moving on to this next one, I could write down the two equations. Y equals, well, either the modulus has no effect, x minus 2, or y equals minus x plus 2. Okay, notice the modulus will either swap the sign of everything inside it, or it will leave it all alone. Okay, but the point of v method says that I need to consider, so the point of the v, so this is becoming a template. The point of the v is when the thing inside the modulus, x minus 2 equals naught. So that gives me two things. It gives me x equals, so x minus 2 equaling naught means that x is going to equal 2, and y is going to equal, well, if the thing inside the modulus does equal naught, then y is going to equal naught. So I'm going to have this point 2 naught at the point of my v. Okay, so I could actually sketch the graph knowing that, so I can get a reasonable sort of sketch by saying the point of the v is at 2 naught, so my v is going to go like this. Okay, and the one that slopes up is going to have positive gradient, so y equals x minus 2 on this side, and this is going to be y equals minus x plus 2. But there's always another point. This is the point 2 naught, but we also always need to worry about the y-intercept. So actually it's a good idea, before I get to sketch the graph, I'll squeeze it in here, to think about the y-intercept. The y-intercept is as easy as it always has been. The y-intercept is when x equals naught. So suppose I take x to equal naught, what does y equal? Well, y, when x is naught, is going to be the modulus of naught minus 2. So y is going to be the modulus of naught minus 2, which is the modulus of minus 2, but the modulus of minus 2 is plus 2. So I'm going to get the point 0.2, so the y-intercept is 2. And that's my sketch. So let's apply this to some more, okay? This one here is weird because it's got an x squared in it. That's a curve. That's a different method. Let's go on to number 4. Okay, so number 4, okay, the point of the v method. So complete template is point of v and y-intercept. Okay, so the method for the point of the v is the thing inside the modulus, x plus 2, has to equal naught. What happens when x plus 2 is naught? Well, x is minus 2. And if I make the thing inside the modulus 0, then y is going to equal 0 minus 3, so y is going to equal minus 3. So the point of my v is now at minus 2 minus 3. And the y-intercept, well, the y-intercept is always when x equals naught. What happens when x equals naught? Well, in this case, y equals the modulus of naught plus 2 with 3 taken away from it. So naught plus 2 is 2, so the modulus of 2 is 2. So it's 2 take away 3, which is minus 1. So the y-intercept is at minus 1. And the point of the v is at minus 2 minus 3. So my sketch graph, okay, I've got a y-intercept at minus 1, and the point of the v is going to be when x is minus 2 and y is minus 3. So minus 1 is here, minus 3 is there. There's the point of the v, and here comes my v like that. Okay, ideally I'd make it look a bit more symmetrical, but that will just about do as my sketch. I could find these x-intercepts if I really wanted to. But what I will add to the graph actually is the equation of each branch. So y equals x plus 2 minus 3. If the modulus does nothing, I'm going to get y equals x plus 2 minus 3 as x equals minus 1. That's got a positive gradient, so it must be on this side, y equals x minus 1. But if the modulus does do a sign swap, it would give me minus x minus 2. And if I can incorporate the minus 3 with that, I can see that this side is going to have equation y equals minus x minus 5. And knowing the equation of each branch can be useful in many situations. Okay, the next one I want to look at is this one down here, y equals modulus of 2x plus 1. So the template says we want the point of the v, and we want the y-intercept. So the point of the v is when the contents of the modulus is 0. So 2x plus 1 equals 0. So solve that. 2x is minus 1, so x equals minus a half. And if the thing inside the modulus is 0, then y is 0. So y equals 0. So the point of the v is minus a half, comma 0. And the y-intercept is when x is 0. And if I take x to equal 0, y is the modulus of 2 times 0 plus 1, which is the modulus of 1, which is 1. So the y-intercept is 1. The point of the v is at minus a half 0. So minus a half 0 could be here. Okay, and the y-intercept is at 1. So for the first time, we've got a steeper v. Okay, and that's because the equation of each side, well, for one side, y equals 2x plus 1. If the moduluses do nothing, I get y equals 2x plus 1. I know it's this side because that has a positive gradient. It has a gradient of 2, which is why it's steeper than the v's we've had before. And this side is when the modulus does something. So if the modulus does something, it causes a sign swap. So y equals minus 2x minus 1 is the equation of that branch. Okay, so that was number 5. For number 6, let's have a look at this one here. Let's look at y equals 3 minus x plus 2. Now from the work on transformations, you're probably knowing what that minus in front will cause, okay? We're going to see it happening with this method. With the point of the v, so the point of the v is when the thing inside the modulus is 0. X plus 2 equals 0 means that x is going to have to equal minus 2. And if this equals 0, then y is simply 3. So y equals 3, so the point is minus 2, 3. Okay, and the other part of the method is the y-intercept. So the y-intercept is when x equals 0. So y is going to be 3 minus the modulus of 0 plus 2. Well, the modulus of 0 plus 2 is the modulus of 2, which is 2. So this is 3 take away 2. So y equals 1 is the intercept. So put this on a graph. Okay, we've got a point of the v is at minus 2, 3. So that's going to be minus 2, 3. That's going to be here. But then the y-intercept is 1. So when I call it a v, actually this is one like this. The sides of the v slope down. Why does that happen? Because, well, what sort of transformation do we get when we do a minus? Here's the function. This minus is outside the function, so times minus 1 outside causes a vertical change. It's a vertical reflection, but a vertical reflection is a reflection in the x-axis. So that's why my v has turned upside down. Okay, but the point of the v y-intercept method told me everything I needed to know, and as before, I can work out the two equations. So when the modulus does nothing, I'm going to get 3 take away x, take away 2, so I'm going to have 1 minus x, but I've got to be careful here, okay? It's got a minus x on it, okay? So that means it slopes down, but now this side slopes down. So this is going to be y equals the 1 minus x, okay? And then the other side is when the modulus causes a sign swap. So if this is a minus x and a minus 2, I'm going to be doing 3 take away minus x minus 2, which is actually 3 plus x and 3 plus 2. So, well, 3 plus 2 is 5 and plus another x. So this is y equals 5 plus x. So once again, I can get the equation of each branch. So when you have got something inside the modulus and there are no x squareds or anything worse than just a linear function, you can use the point of the v and y-intercept method to reliably get a graph. Or it's quite okay to use your graphics calculator if you've got one. Okay.